Hello guys, welcome. This video is going to be a little bit different from the other ones. This is an actual real phone screen interview with Uber. And this was done back in 2016. And I was a sort of an inexperienced engineer at the time. So looking back at this from where I'm at right now, I can see I've made a lot of mistakes. But fortunately, this was a successful interview, and I was actually invited on site after this performance. In the on site, I didn't get the offer at that time, but I felt there was value in showing something that was recorded already. So you guys who are, sort of starting out with just a couple years of experience, get a glimpse of how a phone screen would go, okay? So let me know in the comments what you thought about this interview. It's going to be about an hour long, so apologies for that. If you really stay through and go through this, I really think you can find some value. So I hope you enjoy this video.
Hello,
Hi.
can you hear me?
Yes, I think I can hear you.
Okay, cool. It's the first time that the people can hear me. Yeah, I always they cannot hear me, and I need to use my phone to call in. So that's awesome. You can hear me. All
Yes,
right.
yes.
Okay. This is hi. I'm from Uber. Yeah.
Mm-hmm.
Yeah. You just use my name here, the Nebo Fox. So, how are you today?
I'm good. Kind of a little bit nervous.
Already, no need to be nervous. Yeah, okay, cool. So,
Okay.
tell me a little bit about your background.
Sure. So I'm a junior software engineer at.
Okay.
I've been working for it's about 2 years. I worked. It's my first job out of college.
Okay.
I graduated from.
Mhm.
And I started working. I was a Java developer, and after that, I started working in February 2015. I moved to the Merchant org, so I started working with JavaScript and Node.js. So ever since then, I've been working with JavaScript and Node.js based services.
All right. So basically, it sounds like you are a front-end engineer.
So I also do backend. Node.js is backend.
Right.
You can use JavaScript in the backend as well.
All right. Okay. I think we can start the coding questions.
Okay.
So,
Can I change this to any language I want?
yes, sure.
All right. Let me change this to JavaScript.
All right. All right. Let me. So, my question: can you switch to the draw tab? Draw. There's a code and a draw.
Yeah. Sure.
So, suppose we have a data structure is very like linked list. So, for example, like the normal linked list is like 1, 2, 3, 4, right? So, when this is a normal linked list. So the different thing is for this data structure, I want to add some new things. So for each node, it will have another pointer. Let's call it random. It can point to a random node in this list, like here, like maybe 2.24, 3.24, and 4 point back to 1. So give you this data structure. I want you implement how to copy it. I want you return a copy of this data structure. Yeah.
You want to return a copy of this data structure?
Yes.
Okay.
Let's say we have the head of this, and I want you return the head copy of it. But when you go through it, it's exactly the same structure.
Okay. Let's see. Okay, so you're given the head, and the head object, right? So it's a node. It's the node object, right? And I'm guessing it contains a value, and it contains a next, and then the next key is random. So if I go back to the code, can I show you what I mean? So would you say something like this? var node 1 would have a value 1, and you have a next, which points to n2, and then you would have a random like this. Is this what you're thinking? n3, right?
Yeah.
So that's the object, value, next, and random. And the random points to the node 3, right? Okay. Okay, so let's see. What we could maybe do is we could traverse through the linked list. So you're given the head of the linked list, right? So we traverse through it once until we reach null, right? Because in this example over here, 4's next is null, right? Is that accurate?
Sorry? Okay, so you traverse.
We traverse it once, so 1 dot next is 2, 2 dot next is 3, and 3 dot next is 4, and 4 dot next is null, right?
Yeah.
Okay, so we can traverse it once and create the linked list. And then the next time we traverse it through randomly, and we can connect up the appropriate linked lists. We could try that.
My question is how you do the second traverse.
Sorry, could you repeat that one more time?
I mean, how you do the second? You said the first traverse is only deal with the next pointer, and your second traverse will deal with the random pointer, right? So how you do your second traverse? I mean, how you find your random node?
I see. Let's see. The next one, the random node. That's a very interesting thing. So if you traverse it once, you can get the actual linked list. How can we get the random one? Are we assuming the values? Can you assume that the values are distinct?
No.
Okay.
No.
Okay. So 1 is pointing to 3. 3 is pointing to 4, and 4 is pointing back to 1. So how can we know? 1 dot next could be Yeah, is there perhaps some sort of hint or something, maybe? let's see, 1 points to 3. Yeah, I can construct a linked list by itself. I can get the next guy. It's just the random that seems slightly a bit tough, right? So let's see. Random, null. Okay. Am I allowed to include any other? It has to be an exact copy of this linked list, right? Copy of the values and the next and the random pointers, right? Okay.
Mm-hmm.
1 is pointing to 3, which is pointing to 4, which is pointing to well, 2 is also pointing to 4. Is there a hint that I could use to figure out how the first node's dot random would point to the next random?
Consider so consider that you asked me whether can you assume whether it's unique, right? So think about what if it's unique and how you're gonna solve it. Then how you why you hope it's unique. Find something.
I was hoping it was unique because maybe you could store the value that the random is pointing to in a separate data structure. So 1's random would be pointing to 3, right? And then 2's random is pointing to 4. So maybe you would have a hash map where you could have the key was the node and it's random. The value that it's randomly pointing to would be the value.
Why it's point to the value in that? Think about. I think you are in the right track. Think about
maybe instead of the value, perhaps it could be. Perhaps instead of the value, it could be the object itself, or the object. Maybe not the value itself. Maybe the value. Sorry. Maybe it's the entire object itself that it's pointing to. I don't. So I guess in the hash map, the key would be the node. The value could be. The value should be, I guess, the value of that node, right? Which is 3. So the key is 1, value is 3. But you said the values is not distinct, right? It could be the same.
So what you gonna use as a key?
The node itself.
So think about what value you are gonna use. What's the key value?
Is it the node dot value, or node dot num or something like that? The actual 1, right? The 1 would be the key, right? So the actual key of the hash map. Maybe it's the position. maybe it's 1. The key of the hash map could be 1 pointing to 3 or 0. Maybe we could say 1 points to 3, right? And the next hash map would be 2 is pointing to 4. The next one is the value, or the key 3 is pointing to 4. And the next is okay, let's see. Okay. And maybe so maybe the value is the position of the node, and the key is the position of the beginning node, right? And the random that it's pointing to is the position from the beginning. So for instance, the key is 1 and the value would be 3, right? Because it's 3 away from the root. So is that the way to go about it?
So you mean what you're gonna store for the value?
The value would be the position, like the 3rd position from the root, or the 4th position, the nth position of the node, right?
Kind of, yeah. I think it's position. If you
would that be appropriate to store the position of the node?
It can work, but once you get the position, then you need to. Then what's the time complexity of your algorithm?
So the position is going to be O of n squared, because you would have 1 counter in the beginning, and you would have another counter to count until you get the position of the node, right?
You make it to big O n.
It would be O n squared.
I know. So can you optimize it to big O n?
Oh, okay. Optimize it to O n. Let's see. Maybe we could have another way that I'm thinking is maybe we can have some sort of a stack, and you push all the randomly traversed node into that stack, right? So you would have push 1, and then you push 3, and then you push 4. But no, you would miss 2, right? Your stack might not work here. They can traverse through. Sorry, could you repeat that again?
So what you just said? You stack that?
I was thinking of using a stack, but that won't work because.
Don't think too much. Just think about the hash map and what you're gonna put in your value. Yeah.
The value and the key, right? Okay.
Yeah.
Not sure what I would put as the value aside from the actual value of the node. Maybe the object ID. Maybe the reference to that. Okay, maybe. Oh, okay. So
I mean, why you need use the value of the, no, right? Yeah.
Okay,
Yeah,
okay.
thinking about-
Maybe you can point to the. Okay, so the hash map can contain as the key. So the key is the original object, and the value is the copied object.
Yeah, I think that kind of makes sense to me. Yeah.
Yeah. Okay.
Yeah.
So yep, that makes sense. The key is the original object, and the value would be the copied object. So, for instance, the 1 will point to the copied 1. 3 would point to the copied 3. Yeah, we could try that out.
Yeah. Try that.
Can I code for this?
Yes.
Okay. Function copy linked list. Okay, and this will take the root 1. Root, right? So var, you can use node root 1. So you can keep that. Next, we can do while root 1, while root 1 does not equal to null. Root 1 is equal to, sorry, not root 1, node. Node is equal to node.next. But before we do that, we want to construct our new copy, right? So var copy is equal to, so in JavaScript, you can use an object, right? So I'm going to create an empty object here. So we could do something like copy dot, what we could do is maybe, copy the objects, right? So we do something like for var property, right? So we want to copy all the properties of one object to another, right? Var property in node. We would do copy of property is equal to node property, right? So what this is doing is basically copying from original to the copy, right? Okay. So we're doing this. Then copy is equal to copy dot next. We'll do var copy root copy. Okay. So this while loop over here should take care of copying all the properties from the node to the copied nodes, right? And as we do this, what we should also do is we should make a hash map, or maybe linked map is equal to new map. Map of the linked list map dot set the node itself, and the value is the copy. Right? This is setting the over here.
Yeah.
In the hash map. Awesome. So the next time we need to traverse and set the randoms. So let's do that. Wiring up the random random pointer. So here we would do a node is equal to root1 and copy is equal to copy root. So while node is not equals to null, while it's sorry, I renamed this. I keep calling this root1. This is root. Yeah. While node is not equal to null, node is equal to node.next. Put that here. Inside here, node var random node is equal to node.random, right? And so what we can actually do is, so once we get the random node, we check to see the hash map for copy and then copy or something like that. Let's do linked list map dot get random node. So we're getting the corresponding random copy. Now we can do copy dot random is equal to random copy. Great. So now copy is equal to copy dot next. So do this. Yeah. If assuming a linked list doesn't have a random and it's a null, right? So that's a problem. So let's do a if statement here. Linked list dot has dot random. For copy is equal to null, to do this. Yeah. Cool. So the random copy is going to get the node.random, and copy.random is going to be set to the random copy. And then copy.next, node.next. Yeah. This should node.random. Yeah. So in JavaScript, you might not have to take care of.
Can you write some test? Can you write some test?
Sure. Let me return the copy root, right? Yeah. Okay, so let's write some tests. Var n1 is equal to value is equal to 1. Next is equal to n2. Random is equal to n3, right?
Yes.
Okay. Var n2 is equal to value is equal to 2. Next is equal to n3. Random is equal to, the draw says the random is pointing to 4. Var n3, value is equal to 3. the random or next is equal to n4. Random is also n4. Rn4 next is equal to null. Random is equal to n1.
Right.
Let me put that down here. So
Yeah.
yeah. Sorry?
Yeah. Right. So what if I want to, let me check.
Oh, actually, this might throw a slight problem. So let me do a n4 over here. N4 dot random is equal to n1 because you're declaring n1 afterwards. Yeah. Okay. So maybe I can do a console.log of n1. So you can see if I've created the objects properly or not. Oh. Expected token, unexpected token equal. Okay, let's, yeah. Node.random. Oh, whoops. Extra parentheses missing. Okay, so value 1 dot next is value 2. This is pretty confusing to read, right? How can how can we test this out properly? Next random. Okay, so yeah, this actually looks fine, right? So value 1's next is value 2, and random is 3. But I guess we should print out everything, right? Console.log n2, console.log n3, and console.log n4. So if we run these guys, do you see anything here? Oh, whoa. Okay. Yeah. So this is similar to what you had on the draw screen, right? This is just the...
Let me check. Yeah. So,
this is similar to your...
All right. Let me check. Why there's some error?
Sorry?
Oh, no, never mind. All right. So, how many extra space you used? I think this is all. Yeah.
Sorry?
I mean, how many extra space you use for your algorithm? Because we know that you need the space to store your results, right? So how much extra?
How much extra space? Sure. So I'm using a hash map. So the hash map contains a size of n, right? Because you have n keys and you have n values as well. So the hash map contains O of n space. And you're also making a new object for each object inside your original linked list, right? So that's also O of n. So you have O of n plus O of n, which is O of n. So maybe let me try to invoke this function, right? Copy linked list var copy one equal to copy linked list of n1 console.log copy. We get these guys out here and run that. Or whoops, copy one linked list. Oh, linked list map. Oops. Awesome. I think this is right.
All right.
Maybe we should traverse to this. Let's go through a while loop. While copy one is not equal to null. Console.log copy one is equal to copy one dot next. It should print out. Yes, it looks exactly the same as our original input. Yeah. I'll just copy.
So can you optimize your algorithm to big O1?
To big O1?
Yeah. Can optimize it to big O1 for the space.
I see. Okay. For big O1 for the space, huh? Let's see how we can do that. 1 is pointing to 3.
Mm-hmm.
Yeah, actually there might be a, 1 is pointing to 3, okay.
Mm-hmm. Yeah.
How do we know that 3, how do we know the corresponding 3? Wow, I don't know if we can put this to O of 1. Is there a way?
Like, if we want, I mean, definitely you need the big O1 to store the, definitely you need the big O-N to store your results. But you can, but you can using some like tricky things. Think about how to record your one-on-one map. Yeah.
Okay. Let's see. O of 1 space. 1 to 3. 3 is pointing to 4. 4 is pointing to 1. Okay. 1 is to 3. Mm-hmm. 3, okay. How do we know the corresponding 3 to this object? Maybe what you could do, actually there could be a way. So as you're constructing the copy.next here, right? Maybe you can store copy.corresponding or something like that, and you attach your node to that, right? So maybe something like copy dot am I allowed to modify the original input?
Yes, I think you can.
Okay,
but you needed to make it like you can, but you should make sure you can return it back.
Okay,
like,
sure.
Yeah,
sure. So I can actually add it to this, right? I can do node.copy is equal to copy. So I don't need the hash map. I can just put this here. should I modify the code, or should we save this code and then can I modify it?
Go ahead.
Okay, awesome. So we could remove this guy and remove the hash map. Node.copy is equal to copy. And then we can do copy, node dot copy node dot copy is going to contain the copy, right? So oh man. So node.copy contains the copy right now. So what we should do is, let's put this guy back here. Node.copy. Random copy is equal to copy. So yeah. Yep. Copy.random is equal to random copy. Yes, I think this should work. Let's try. Yep, we got the same, I think we got the same results. Yep.
All right. So.
Oh, let me remove the copy. Right, I should do a copy dot. Before this node dot copy is equal to null, right? Because we wanna delete that, right? Yeah.
Let me check. So let's clear this. And how you made it? So. There's something not right here. How you do that?
Could you repeat that one more time?
I mean, I feel something not right. So can you go through your code?
Sure. So inside here, we're inside line 9 to 20. We're looping through the linked list, and here we're copying the properties of the node into the copy object. But what we're doing is we're attaching the copy into node.copy. So we're creating a new property called copy. So maybe we could call this something else, copy prop. Maybe that might be more clearer. So we have a new property called copy property where we're attaching the copy object.
So you create another pointer called copy?
Yes, a copy prop.
Then you basically you changed your
hash map into this, yeah.
You changed your original data structure, right? Suppose we do not have another point. So right now you have 3 pointers for each node, right?
Yes. But inside here, I'm removing the pointer. In line 32, I'm removing it.
Suppose I think, how about because originally I do not define copy.
I see.
I do not. Yeah, we have only 2 pointers. So basically you add one. Yeah.
So should I have modified copies property then?
Never mind. I think no. Never mind. I think it's okay. Yeah, I think we can use the time left to have some Q&A questions. Yeah, actually I like your idea. Yeah, it's no problem. Yeah. So can you like yeah? So do you have any questions?
Yeah, I was hoping of what your role was in your company. How long have you been working at Uber, and what are you working on?
I've been working in Uber like for 1 year, and I'm working in the money team. So basically, I'm working on their payment processor, and and also some build some tools and some anomaly detection service for their payments. Yeah, that's basically what I'm doing here. Mm-hmm. Yeah. All right. So I think you did.
New grad. Sorry.
Yeah. No problem. Yeah, you already have the experience. I think you have 2-year experience. It's not actually that junior already. Yeah. All right.
Awesome.
All right. I think we can. Yeah. And here, do you have any other questions?
No, that's it. Yeah.
Pretty good. Okay. Thank you. Thank you very much.
Thank you.
Bye.
Bye-bye.